Good morning, everyone. Happy day, what is this, day number 4 or 5 or 3 of eLearning? I'm going to be honest, I can't keep track of the days. Alright, so today we're going to do the ideal gas law, and I know we didn't really talk about it in class, but it's actually pretty easy to use. So if you look at the study guide, the ideal gas law is down here at the bottom of this one. It's PV equals nRT. Alright, so this P here is going to be the pressure, and the pressure has to be in atmospheres. The V is volume. The N is the number of moles, or the amount of gas. R is this special number, it's a constant, and when I say constant, it's always the same number. It's 0.08206. And you'll just memorize that number eventually. And then T is the temperature, and the temperature is going to be always in Kelvin. And to get to Kelvin, we just add 273 to the Celsius temperature. Alright, so let's look at the first problem here. It says, what is the volume of a gas if 0.182 moles of the gas is at 1.99 atm and 83.4 degrees Celsius? So again, remember the formula is PV equals nRT. And they're all multiplied together. Alright, so it wants to know what is the volume of a gas. So the volume here, our V, is going to be our X. Alright, if 0.182 or 0.182 moles, alright, so moles is going to be our N. It's going to be number of moles. That's how I remember it. Alright, so I'm going to put a little N above that to let you know that it's the N. So this is going to be 0.182 moles. Alright, 1.99 atm, that is going to be a pressure. So remember, if it's atm, if it's mmHg, all those different things, and it's going to be a pressure. So I'm going to put a P there like that. Alright, so now I'm going to write 1.99 atm there. Alright, this 83.4 degrees Celsius, that's going to be a temperature. So I'm going to put 83.4 degrees Celsius there, but you have to add 273 to it. So I'm going to add 273, and why am I adding 273? It's just so that we can get it into the Kelvin temperature. So I'm going to take out my calculator, I'm going to do 83.4 plus the 273, and that's going to equal 356.4, and that's going to be in Kelvin. Alright, and now you may be asking, you'll be saying, okay, well, I've read the entire problem, and now I'm still missing this R number. So the R is always going to be a constant, and it's going to be 0.08206, just like that. So every single time you have an ideal gas law problem, you're just going to fill in that number. Okay? So now I'm going to do this on another sheet of paper because there's really no space on this sheet of paper. So I'm going to write the formula P times V equals N times R times T, just like that. And then we're going to plug in the values for what we're given. So the P was 1.99, so I'm going to write 1.99 times the V, which was X, so times X, equals the N, and the N is going to be 0.182 times the R, and the R is going to be the same number, this 0.08206, times the temperature, which is 356.4. Alright, to solve this, it's just going to be like doing algebra like we have been doing. Alright, so on this side it's going to be 1.99 times X, so that's just going to be 1.99X, equals, and then on this other side, on the right side, we're going to multiply all three of these numbers together. So I'm going to multiply 0.182 times 0.08206 times 356.4. Alright, and that's going to give me 5.3228. Alright, and now we're left with this 1.99x equals 5.3228. Alright, to get the x by itself, I'm going to divide both sides by this 1.99. Okay? And x is going to be equal to So 5.3228 divided by 1.99. Alright, the answer that I have is 2.67. And the units for volume for the ideal gas law, it has to always be in liters. So this is going to be 2.67 liters. So X is going to be equal to 2.67, and it's in liters just like that. Okay? So that's how you do that one. And again, remember, pressure is going to have to be in atmospheres. The N is the number of moles, so it has to be in moles. The volume has to be in liters. This R is 0.08206, and the temperature has to be in Kelvin. And you can get to Kelvin by just adding 273. Alright, so let's go on to the next problem. It says, at what temperature would 0.46 moles of a gas occupy 13.3 liters if the pressure is 734 mmHg? Alright, so let's read through this. It says, at what temperature? So our temperature is just going to be X. And remember, if it's X, whenever it comes out of the formula, it will automatically be in Kelvin. Alright, so this 0.46 moles of a gas is going to be the N. Alright, because N stands for number of moles, or that's the way I think about it in my head. Alright, the next one we have is going to be 13.3 liters. Alright, so this is going to be your N. This is going to be your volume. So 13.3 liters goes here. Alright, P is 734 mmHg. But whoops, that is a problem. Why is it a problem? Because we have to use atmospheres in the ideal gas law. So we can't have this 734 mmHg. So what we're going to do is we're going to convert the 734 mmHg into atmospheres. And the way that we can do that is we can just divide this number by 760. Because remember, there's 760 millimeters of mercury in 1 atm. So hopefully you remember doing all those conversions. So I'm just going to divide this by 760, and that's going to get it into atm. So in my calculator, I'm just going to do 734 divided by 760. And that'll give me 0.965789. So I'm just going to round this to 0.97. Alright, so this is going to go here, 0.97, and it's going to be an atm. Alright, so now again you may be questioning, you're saying, well, we still are missing this R value, and I don't know how to get the R value. Remember, the R value is always going to be a constant, so it's going to be this. It's going to be 0.08206, just like that. Alright, so now I'm going to do this on another sheet of paper. Alright, so let's move this up a little bit. Alright, so here's my formula again. It's going to be P times V equals N times R times T. Alright, so remember, if I'm going too fast or something, or if you need a second to fill in the blanks or something, just hit pause on the video. I'll still be here, and you can just follow along like that. Alright, so now P times V on this side, we're going to have to use the ATM value up here. So instead of using 734 mmHg, we have to use this 0.97 ATM. So 0.97 ATM, right, times the volume, which is 13.3 liters. And you don't have to write in the units as you work out the problem. I'm just doing it to show you that we had to use the 0.97 ATM. Alright, next thing we're going to do is we're going to plug in the N value, which is 0.46, times the R value, which is that constant at 0.08206, times X. Alright? Because X is the temperature, that's what we don't know right now. Alright? So now we are going to, on the left side, we're going to multiply these two numbers together. So we're going to multiply this 0.97 times 13.3. And that's going to give me 12.901. So on the left side here, I've got 12.901 equals, on the other side, we're going to multiply the 0.46 times 0.08206. And that's going to give me 0.0377. So 0.0377. But we've still left with this times X. And now to get the X by itself, since this is multiplication, we have to do the opposite of multiplication, which is division. So I'm just going to divide this side by 0.0377 to make the X, or get the X by itself. And then whatever I do on one side, I have to do on the other side. so now we're going to get 12.901 divided by 0.0377, and that's going to give me 342.20 equals x. Alright, and since this is a temperature, since temperature was x, the units for this is going to have to be in Kelvin. Alright, so now I'm going to fill that in up here. It's going to be 342.20 Kelvin. And there you go. That's the answer to that one. So remember, again, if you get behind or something like that, just pause the video and then work ahead with me, or, catch up, and then we can get right back on the same track. Alright, so now let's move on to the next one. The next question, number 10. Alright, so it says, what is, or how many moles of a gas would occupy 157 liters at 1.30 atmospheres at negative 16.8 degrees Celsius? Alright, so let's read this question again. It says, how many moles of a gas? Alright, so the moles, remember moles is N here, because it stands for number of moles. Alright, so the N is going to be X. Alright, would it occupy at 157 liters? Alright, so liters is a volume. Remember, you can buy sodas in a 2-liter at the grocery store. Alright, so we're going to put that here with the volume, 157 liters. Alright, the pressure is going to be this here. It says 1.30 atm, and atm stands for atmosphere. So I'm going to put that here, 1.30 atm. And remember earlier on the study guide where we had to list out the units for pressure, and it was ATM and mmHg and PSI and torr and kPa and all those. Alright, so now the next one it says is negative 16.8 degrees Celsius, so negative 16.8 degrees Celsius. And we're going to have to add that fancy number to it, that plus 273. Alright, so negative 16.8, I'm going to do that in my calculator, so negative 16.8 plus 273, that's going to give me 256.2, and I'm going to fill that in right here. Alright, and then again, you may be asking, you may be saying, okay, well, how do I get this R value, or this R number? Remember, the R number is always going to be a constant. It's going to be 0.08206, just like that. Alrighty, so now let's do that on another sheet of paper because I don't have a lot of space here. So let's write out the formula again. So we're going to do P times V equals N times R times T, PIV NERT, if you will. Alright, so the P here is going to be 1.30 atm, or atmospheres. So 1.30 times the volume, which is 157. Alright, so I just pulled that from here, the liters. Alright, the N is going to be X times the R, which is 0.08206, times the temperature in Kelvin, which is going to be 256.2. Alrighty, so now on the left side, let's multiply the 1.30 times 157, and that's going to give me 204.1 on that side. Alright, and then on the right side, we've got X times 0.08206 times 256.2. So I'm going to multiply these two numbers together, and then I'm just going to have that with the X here. So 0.08206 times 256.2. Alright, that gets me 21.02, but remember it's still times X. Alright, so now, if we're looking at this, we're going to have to say, okay, how can we get the X by itself? And to get the X by itself, we're going to divide both sides by this 21.02. Why are we dividing? Because this is multiplication. We're doing the opposite to get the X by itself. Alright, so 21.02. Now on my calculator, I'm going to do 204.1 divided by 21.02. And that's going to give me X equals 9.7, and I'm going to round mine. It's 9.7098, so I'm just going to round mine to 9.71. Alright, so now that's our X. And then looking here at the problem, X was N, which stands for number of moles. So I'm just going to put 9.71 moles there. So X is going to be equal to 9.71 moles. And that's a lot of moles. If it was oxygen gas, it'd be like 9 times 32, which is a lot of grams. All right, last one. Wow, I know you're so sad about this. It's the last one. All right, so it says, what is the pressure? Okay, so it says, what is the pressure? So that's the P. So P is going to be X, our unknown here. If 1.42 moles of carbon dioxide gas, CO2. All right, so I'm going to put, this is moles. So remember, moles is in, because it's number of moles. It's 1.42 moles here of carbon dioxide gas, and it just tells you carbon dioxide is CO2. I don't know why they gave you that information. It's kind of just, you don't really need it. If it occupies a volume of 35 liters, so that's a volume, so I'm going to put a V there. So 35 liters goes here. Alright, at 0 degrees Celsius, so 0 degrees Celsius. But don't forget, we have to add that fancy number, that 273, to get it into Kelvin. So 0 plus 273, I mean, you can do that on your calculator if you want, but it's going to be 273. Alright, and now we have another question. We still have one missing blank, which is this R. So if you want, you can search the internet, or if you just remember that it's the same number as it always is, it's the 0.08206, 0.08206. Then you can fill in all the blanks and only have one X, and now you can solve for X. Alright, so I'm going to do this on another sheet of paper because I'm out of space again. Alright, so here's the formula. P times V equals N times R times T. Alright, so our P, our pressure, is going to be our X. We don't know what that is. So it's going to be X times the volume, which is 35 liters, equals N, which is 1.42, so 1.42 goes here, times our R value, which is 0.08206, times the temperature in Kelvin, and it's going to be 273, so multiply that by 273. Alright, so now on this side we're going to have just X times 35, so that's going to be 35X, equals, and now I'm going to do 1.42 times 0.08206 times 273. On my calculator, I got 31.81. Alright, and now, to get this X by itself, I'm just going to divide by 35 on this side. And whatever I do to one side, I have to do to the other side. Alright, so X is going to be equal to 31.81 divided by 35. Alright, and that gets me 0.90885, so I'm just going to round mine to 0.91, and it's going to be an ATM because it's a pressure. Alright, so now you can fill in the 0.91 up here, so X is going to be equal to 0.91 ATM. Alright, and look at that, we have solved the entire study guide. So remember, if you have questions, you can always email me, you can comment on Google Classroom. Hopefully you're getting these practice problems, that kind of thing. Again, if you have trouble, pause the video, come back to it, that kind of thing. Hope you're having a great day.